Okay, so we'll talk about 6.2 homework and 6.5 in class as well as homework if you have solved. Okay, so we'll solve some problems, we'll clear your doubts. Just wait for 1 more minute for everyone to join. Okay, we will start now. Okay, we will start now. So we will start with 6.2 homework. It's been a week, right? Okay, so I hope all of you have gone through the problems of 6.2, right everyone? We have already discussed pre-reading and in-class exercise. We have already discussed in-class exercise. So we'll talk about homework. So homework question 1 and 2, any doubts? 1 and 2, homework 1 and 2, any doubts? If you have any doubts, please message. Everyone, please message your doubts. Okay, so let's see question number 1. Everyone just see question number 1. So question number 1 should be very easy, right? It's basic formula putting getting. Write on the data. Write on the data. So what are the data which is given here? So Q, right? It is losing. It is losing. Means Q is negative, minus 65, right? Delta Q. The gas contracts as it cools down and work done is equal to 22 joule. 22 joule, right? This is your work done. Now this work done is due to contraction. Means volume is decreased, which means delta V is negative. So work done, which is minus P delta V. P delta V. Since delta V is negative, minus P delta will be positive. That's why I've written positive. Okay, everyone? Now you have to find delta U. It's basic formula putting getting. Can you solve it? Right, everyone? I guess you can solve it now. Right? Yes. So delta U is Q plus W, which is minus 65 plus 22. So it should be easy. It should be minus, tell me, 43 joule. Easy? Okay. Now let question number 1 done to 3 to 7. 3 to 7. 3 to 7. Everyone, any doubts between question number 3 to 7? Tell me everyone. 3 to 7. 6, 7. Okay. Before 6, 7. 3, 4, 5. I guess 3, 4, 5 everyone should solve. It's easy. Right, everyone? Okay. 6, 7. So we will discuss 6 and 7 first. Okay, everyone? Okay. So let's see question 6 first. The pressure exerted on 1 mole of ideal gas as 2 atm. First of all, write down all the information. As always, write down all the information. Okay. So what are the information given? N is equal to 1. I'm just writing over here. Wait, I'll just solve it. Yeah, it's better. So this is question number 6. So write down all the information over here. N is equal to what? 1 mole. P, right? 2 atm. Which P? Suppose it is P1. T1, it is 300 Kelvin. Okay. Now, is suddenly reduced to 1 atm while heat transfer to maintain the initial temperature of 300 Kelvin. Okay, right? Now, it is suddenly. See the word suddenly, right? Just have to see the word suddenly. So what is the meaning of suddenly? Which kind of process it is? Tell me. Which kind of process it is? Yes, very good, right? So it is your irreversible process. Okay, so that's what you have to identify now. That's what I said, right? So this is P internal actually, right? And P external is given as 1 atm and temperature is constant. So what you have to find first? First you have to find work done, right? So work done is easy, but before finding work done, right, you have to find the formula of V. We know that V is equal to nRT by P, right? So work done is equal to minus P external into V2 minus V1 is equal to, now what is P external? Tell me everyone, what is P external? It is 1, so minus 1, and V2 is nRT by, tell me, P2 minus nRT by P1. That's what we have studied, right? So minus nRT, we can take common because P2 is 1. So 1 minus 1 by P1. Now, can you just put the value and solve? Tell me, can you just put the value and solve? After putting the value and solving, we should get something around, tell me. Tell me, minus 12.3 atm liter. Okay, we should get something around minus 12.3 atm liter. Okay, right everyone? Now, this is your work done, which is negative. So you have to find what? Q, heat absorbed. So we know that Q is equal to delta U minus W, right? And since temperature is constant, delta U is 0, it will be minus W, which is equal to again 12.3 atm liter. Okay, got it? So it is positive, which means heat is absorbed by the surrounding. Okay. Okay, so this was question number 6. Just go through this once, then we'll solve question number 7. Okay, I guess all of you have gone through this problem. Let's solve question number 7. Okay, so let's see question number 7. So we have 2.8 gram of N2. So you can find number of moles of N2. So number of moles of N2 is equal to 2.8 by 28. Yes or no? Tell me. Yes or no? Right? And temperature is given as 300 Kelvin. Pressure is given as 20 atm. Now this is allowed to expand isothermally against a constant external pressure. Just See this, against a constant external pressure. Okay, so doesn't matter, right? Which formula you have to use? Tell me, first of all, tell me which formula to use. Because if you might be using, how many of you using this formula? Minus nRT ln V1, V2 by V1. How many of you using this formula? Tell me. Is there anyone who was using this formula? Anyone? Or using this formula is correct? Can we use this formula? Tell me everyone. Can we use this formula here? Yes or no? Tell me. Can we use this formula over here? Yes or no? No, we cannot use this formula over here. We cannot. No, cannot. Why? See the problem. See the problem. Constant external pressure. Got it? So we have studied that doesn't matter which process it is. If we have constant external pressure, work done will always be minus P external V2 minus V1. Yes or no? Tell me. How many of you remember this? Tell me everyone. Okay, very good, very good. So most of you remember this. Very good, right? So we know what is N2. So W is equal to P external is already given, which is 1 minus 1. Now V2 minus V1, V2 minus V1, right? Okay, tell me. So it is, can you calculate V2? Tell me, can you calculate V2? So let's calculate V1 first. So V1 is equal to nRT by P, nRT by P. So N is 0. Tell me 1 into R is 0, tell me 8.314, right? But here we have to use PV is equal to nRT, so it will be 0.0821 because we are using ATM liter, so it won't be 8.214. That's what OS, it won't be 8.214 because we are using PV is equal to nRT now, so it will be 0.0821. Okay, right? And then we have temperature as 300 Kelvin by pressure we have 20 atm. Got it everyone? So if you solve this, right? So 8 into 2, it's just imagine 8 into 3, 24, or 41 into 3, 12. So it's something around 1 V1 should be something around 0.124 or 123, something like this liter. Yes or no? Tell me. Right? 123 actually. Right? It's pretty easy. 41 into 3 is 123. Right everyone? So this is V1. Everyone agree this is V1? In the same way, we can calculate V2 because what has changed? Pressure is now this 1. So it will be 0.1 into 0.082 into 300 by 1 by 1. So definitely the volume have increased to twice, as simple as that. Volume has increased to, right, not twice, 20 times, sorry. So V2 will be equal to 20 times is 2.46 liter. Yes or no? Tell me, yes or no? So just put the value 2.46 minus 0.123, right? This is your answer in ATM liter. Okay, this is your answer in ATM liter. So it will be what? It will be minus of 2 point. Okay, and this is 733. Okay, 2.337 ATM liter. Got it everyone? Got this, right? So in joule, you just have to multiply by ATM liter. In order to convert this into joule, just multiply by what? I've told you, right? What? 101.3. Yes, everyone, remember? Right? Yes, very good. So this will be in Joule. So you got your work done, right? And it is isothermal, so delta T is 0. So this Q is equal to minus of W. So this is, if you calculate it, it will be something like 236. 236 joules. Okay, everyone, got this? Question number 7. Tell me, everyone got this question number 7? Nishita, Samya, Reshma? Okay. Okay, everyone. Next problem. Just watch video once again. Okay. Next. We just calculated V using PV is equal to nRT and put in the formula. That's it. That's what we did. Okay. 8 to 10. Everyone, 8 to 10. Any other problems? 8 to 10. Tell me, 8 to 10. We have already solved question number 8 in the classroom, all right? How many if you remember? We have already solved question number 8. Something a similar question like question number 8 in classroom. How many if you remember? Tell me. Right? Yes. Okay. Most of you remember. That's why I keep saying please watch the videos. Okay. Question 9. Let's see question 9. We have already discussed question number 8, right? Just the data is changed. Instead of P, it was half P. Instead of 2P, it was P. Instead of V, we had half V. Instead of 2V, we have V, right? Otherwise, it was the same problem. Yes, remember everyone? Okay, question number 9. Let's see question number 9. Now, question number 9 is formula putting getting. Yes or no? Question number 9 is formula putting and getting. What's the doubt in question number 9? Tell me, what is the question doubt in question number 9? Because it is just formula putting getting. What's the formula of isothermal reversible process? Tell me. What is the formula for work done in isothermal reversible process? I just said that. What is the formula? Jitendra, tell me, what is the formula? Jitendra, tell me, what is the formula? Message. So how can you say that you have a doubt? I just wrote the formula. This is the formula that I wrote, right? How can you not remember? This I just wrote like 10 minutes before I wrote this formula. How can you say that you don't remember when I have written it 10 minutes before? Okay, question 9 is just formula putting getting, right? Just the formula, W is equal to minus nRT ln. See, this is ln, right? V2 by V1. Now, in order to convert this into log, we have to multiply by 2.303. So, minus 2.3 nRT log V2 by V1, right? Just put the formula, and we know that for isothermal process, delta U is already 0 because we are discussing isothermal process only. Question number 8, we did the same thing. Okay, question number 10. Anyone having doubt in question number 10? Question number 10. Mansi, Samya, Anjali, Pritam is not here, I guess. Pritam is here. Priyanka. There are 10 students who are missing. There are 10 students who are absent. Sania is here. Sania is also, yeah, Sania is here. Jasharan is here. Meet is here. No one have any doubt in question number 10? Everyone? No one is having doubt in question number 10? Okay. I guess that no one is having doubt. Okay. See, if you remember the concept, I just told you, right, that for cyclic process, the work done is area under the curve. Yes or no? Tell me. How many of you remember this? For a cyclic process, work done is area under the curve, right? So this is your circle. Yes or no? This is your circle. So the answer, the work done is just your area under the circle, which is pi r squared, right? And we know that in cyclic process, delta T is 0. So Q is equal to work done, magnitude wise, obviously. Okay, everyone? Jitendra, I asked you a problem 2 days before when you answered me that delta U is 0 for a cyclic process. Okay? You said delta U was 0 for cyclic process, and I asked you the same problem. Why it will be 0 in cyclic process? When we were discussing 6.1 in class exercise. And I explained everything. What is the meaning of cyclic process? Why delta U is 0 in cyclic process. Okay, so I won't be responding to your these kind of questions if you're not putting any effort. If you're not even answering the same question that I've asked to you only a couple of days back. Okay. Just see the recording. I asked the same question to you only, and you answered me that delta U was 0. And I asked you why it will be 0. Then I explained, I spent whole 20 minutes to explain why cyclic process and cyclic process delta U is 0. Because the initial step and final step is same. That's why delta T is 0. So delta U is 0. Right, everyone? Everyone remember this? Tell me, everyone remember this? Okay. Okay. Question number 11 to 13. 11 to 13. Everyone, question number 11 to 13. Tell me, any doubts? Question number 11 to 13. 12, okay. See, if you don't get any concept, I'm asking like 10 times in the same classroom, okay? But if you're asking me the same formula after 2 or 3 days, right, I won't be replying to you at all, because if the effort is being put by teachers, there should be some effort which should be put by the students, okay? So let's see question number 12 first. We have already solved question number 11, I guess. All of you remember? We have already solved question number 11. It was in the in-class exercise. Question number 12, see question number 12. Right, just go through the problem, everyone. Okay, so see, in this problem, question number 11, sorry, question number 12. This is question number 12, right? Yes, Karishma, initial state and final state are same in cycle process. Very good. So work done in expansion of ideal gas, right? So just write down all the information. First of all, write down all the informations. Work done in expansion of ideal gas from 4 liter to 6 liter against a constant external pressure of 2.5 atm was used to heat up 1 mole of water at 293 Kelvin. If the specific heat of water is this, what is the final temperature of water? First of all, tell me what is the formula of heat gained or heat lost if temperature is given and specific heat of water is given? Tell me, is it ms delta T? How many of you remember this? Tell me, how many of you remember this? It is ms delta T. Tell me, anyone, what is m over here? Right? We'll have weight is equal to its molecular weight, which is equal to 18 grams. So this is 18 into specific it is already given, which is 4.2 kilojoule. So it is 4.2 to the power plus 3 kilojoule into so we know that work done is given. Work done is minus V external into V2 minus V1. And external pressure is 2.5 atm. So minus 2.5 into V2 is 6 minus V1 is 4. Now since it is an atm liter, we have to convert into joule. So into 101.1 because this answer, this Q is in joule. This is in your joule. So this should be in also in joule. Yes, everyone, got this? Tell me, got this? Yes or no? And this should be equal. We know that Q is equal to minus W. So it should be equal to 2. Delta T from here? Tell me. Can you find delta T from here? Right? So you can find delta T is equal to 2.5 into 2 into 101 divided by 18 into 4.2 into 10 power 3. And we know that delta T is T2 minus T1. Okay. Okay, everyone. So I guess everyone got this problem, right? Okay, my voice broke, yeah? It's fine now, right? It's fine. It might be because of a call or message. Okay. So this was question number 12. Just go through it once. Anyone have any doubts? Tell me. 13, 14, 15. We will solve each and every problem. 13. See question number 13. 13 is, see 13 is easy, huh? Right? 13 is basically formula. That's it. Specific heat. Specific heat, right? Which is, tell me what is specific heat? Okay, everyone, right? So I guess you can see the screen. Everyone can see the screen now? Yes. Okay. So we were talking about question number 13. Now, just see our concept. What was our concept? Our concept was Cp minus Cv is equal to R. But this is a heat capacity at constant pressure and heat capacity at constant volume. Yes or no? Tell me. It was not the specific heat capacity. It was normal heat capacity. And what is the relationship between specific heat capacity and capacity? So specific heat capacity, let it be C dash P, is your heat capacity by molar mass. Yes or no? Tell me. Yes or no? Capacity is equal to heat capacity mass. Right, everyone? Right. So in the same way, C dash V is equal to Cv by M. Cv by M. So let's rewrite this equation. So I can write like this: C dash P by, or just write like this. Wait, I can write like this: Cp minus. Now we know that Cv is equal to, tell me, Cp by gamma. Yes or no? Cv is equal to Cp by gamma. So I can write like this: Cp by gamma is equal to R. Right? This is your first statement. Sorry, second statement. First statement is, second statement is this. Now C dash P, right? Cp can be written as C dash P by M minus C dash P by gamma M is equal to R. Can you find C dash P? C dash P, tell me, what is C dash P? It is R capital M into gamma divided by gamma minus 1. Yes or no? Rm by gamma minus 1. Which is the answer? Tell me. What is the answer? Okay, we have no answer, yeah? Okay, wait. Apologies, guys. I made a small mistake, right? This Cp by Cv is equal to R. This was for 1 mole, na? Right? This was for 1 mole. This was for, yes, this was for molar heat capacity. Molar heat capacity, right? Apologies. So it will be something like this. So this is your molar heat capacity, right? So molar heat capacity is, tell me, molar heat capacity is of 1 mole, Okay, molar heat capacity is for 1 mole. This is the definition error, right? Now, specific heat capacity is for 1 gram. Okay, got it, everyone? Right? Specific heat capacity is for 1 gram and molar heat capacity is for 1 mole. And we know that for 1 mole, what is the weight? It will be m grams. So for 1 gram, it will be divided by m. Okay, got it? So this equation will be written as Cp dash Cp minus 1 mole. This is for 1 mole. R for 1 mole. Okay, for 1, tell me, for 1 gram, it will be Cp minus or Cp dash minus Cv dash is equal to R by M. Okay, you will divide everything by M now, right? So we studied C dash P by M. Sorry. C dash P is equal to Cp by M. So we'll divide everything by M now, right? We'll divide everything by M. That's what I have written. I just forgot to write here. So C dash P minus C dash P is equal to R by M. So rest, it will be same. C dash P minus C dash P by gamma, right, is equal to R by M. Okay. So the answer would be A. Right? Answer would be A. Okay. So that was question number 13. Question number 14, everyone. Question number 14. Any doubt in question number 14? Tell me, everyone, question number 14. Okay, let's solve question number 14. I guess most of you haven't solved question number 14. So let's solve question number 14. So everyone, please solve question 14. Everyone should solve question 14, right? Step by step. So I told you in thermodynamics, the first thing that you have to do is find the process. Find the process. So it's already given. What's the process? Tell me, what's the process? Okay, so it is given. It is adiabatic against constant pressure. Okay, so write down first of all what is final temperature, final volume. So in order to find, so it is in order to find what? Final temperature, final volume. You should have final, so initial pressure, initial volume, so initial pressure P1, right? Or internal pressure is given. What is that? 1 atm or 1 bar. 1 bar. Temperature is 300 Kelvin. Number of moles, 1. Right? Now, what is V1? Tell me, what is V1? V1 is nRT by P1. Yes or no? Can you find? Tell me. And since it is given 1 bar, which is 1 bar is equal to how much? 1 bar is equal to how much? 10 to the power 5 Pascal. 1 into 10 to the power 5 Pascal, yes or no? 1 bar, OS. Yes, very good. So it is 1 bar is equal to 10 to the power 5 Pascal. So let's put the value here. So N is 1 into R. Since we are using SI unit, so R is 25 by 3 into T, which is 300 by P1, which is 10 to the power 5. So this is your V1. So if you calculate, you will get something, right? So we can calculate 3 will get cancelled, 100 will get cancelled. It is easy. It will be 0.025 meter cube. Yes or no? Tell me. This is your V1. Yes or no? Okay, very good, very good. Right, very good. Now see, I told you that if we have given this constant pressure, again constant pressure of 0.5 bar, then what is the formula for work done? Tell me, will be the formula for work done? It is always minus P external into V2 minus V1. Yes or no? Tell me. All if you remember, yes or no? Right? Okay? Okay. Now let's see. Let's have equation. So we know that for adiabatic process, delta U is equal to W. Yes or no? How many of you remember this? So I can say that N is 1. So it will be CV delta T, which is T2 minus T1, is equal to this work done, which is, tell me, minus P, which is 1 into 10 power, sorry, 0.5. Sorry, it is given 0.5 now. External pressure is 0.5. 0.5 into 10 power 5 into V2 minus V1. V2 minus V1, which is 0.025. Now this is my first equation. Yes or no? This is my first equation. Yes or no? Because we know what is T1. Since it is monoatomic, CV is 3 by 2R. T2, we don't know what is T2, minus T1, we know it is 300 Kelvin, is equal to minus 0.5 into 10 to the power 5, right? V2 minus 0.025. This is your first equation. What about second equation? So we know that P2 V2 is equal to nRT2. Yes or no? Tell me. Yes or no? Right, everyone? Yes. So we have two equation, two variable, because P2 we know P2 is 0.5 into 10 power 5. V2 we don't know. N1 we know. R 25 by 3. T2 we don't know. Right? So this is equation 1, this is equation 2. Can you solve this linear equation 2 variable? Tell me, can you solve this linear equation 2 variable? This problem is actually hard or easy depending on your calculation. Conceptually, it is not that hard, right? But you have to solve linear equation 2 variable. Okay, everyone? Everyone is getting this? You got this or not? Tell me. All of you got this? Yes, everyone, just raise your hand. All of you got this? So you can solve. Anjali, Priyanka, Kritika is here. Kritika is absent in last class. Aksha, everyone is getting this? Pradyuman, Pradyumna? Okay, very good. So this is question number 14. See, just go through the concepts, right? Just take a minute and try to see the concepts. Okay, so I guess all of you understood the concepts. Let's see question number 15. Okay, let's see question number 15. Just go through the question, everyone. Just go through the problem, everyone. Go through the problem, everyone. Just read this problem once. Okay. Read this problem. We'll try to solve. I'm giving you 2 minutes. Okay. I'm giving you 2 minutes. Everyone, please try this. Okay. This is in class exercise of 6.5 gives free energy entropy. So before 5, any doubts? No doubts. Okay, let's see question number 5. Let's see question number 5. So what is question number 5? Assuming ideal behavior, what is the entropy change associated with mixing 1 mole of N2? Just read the question. 1 mole of N2, okay, with 1 mole of O2. As simple as that. 1 mole of N2 with 1 mole of O2. Right, everyone? Okay, let's see. So we know that. What we know? We are mixing N2 and O2. So initially, right, initially, we had only 1 mole of N2 and initially we have only 1 mole of O2. Yes or no? Tell me. Yes or no? Right? So we have some entropy with this. So suppose we had initial volume V1 and temperature is same and pressure is same also, right? So initial volume will be V1, which is fixed, right? And this also V1, right? Because 1 mole of gas have same volume. Yes or no? Tell me, yes or no? Just see how easy this problem is. We know that delta S is equal to NCV, NCV, right? ln T2 by T1 plus NR ln V2 by V1. Yes or no? Tell me, everyone. Yes or no? Tell me. Yes, very good, very good. Now, since temperature is constant, this will be 0. Now, I hope all of you are getting this, right? I hope all of you are getting this. Okay, very good, very good, very good. So we can calculate this. So let's see. Let's see. So we know that delta S mixing, delta S for mixing will be R, because N is 1, ln V2 by V1, V2 by V1. Now tell me, what is the initial volume? Because now it is mixed. So if initial volume is V0, V2 will be 2V0. Yes or no? Tell me. Anyone who disagree with this? Right? Delta S of O2. Anyone who disagree with this? Right? And delta S of N2 will be also R ln V2 by V1 because number of moles are same. Yes. So can I say that delta S total is equal to delta S of N2 plus delta S O2? Everyone, can I do that? Equal to what? R ln 2 plus R ln 2, which is 2R ln 2. Got your answer? Tell me, got your answer? Ronak, Shreya, you got your answer? Okay, very good. Now we are done with question number 5. 6, 6, 7. Question number 6, 7. Any doubts in question number 6, 7? Ask. If you have any doubt, please ask. So we have 15 students absent now. Very good. Okay, tell me. Sixth. Okay, Ria, sixth. We will discuss question number sixth. Let's see question number six now. So what is given? This is your reaction. This is your reaction. Just think about this. Entropy changes this at this temperature. Okay? In spite of negative entropy change, why this reaction is spontaneous? Now, what is the meaning of spontaneity? Delta S, right? Can delta S alone, tell me that a reaction will be spontaneous or not? Or is it something else? Tell me. Is it something else? It is delta G, right? It is delta G which will let us know about spontaneity. And delta G is equal to what? Delta H minus T delta S. Yes or no? Tell me. Yes or no? Yes or no? Okay, very good. Now, delta H is already given, right? Okay, so first you have to find what? Delta H is already given. Can you find delta G? Tell me, can you find delta G? Now everyone getting this? So delta G is equal to minus 1648 into 10 power 3 minus temperature is 298 into delta is already given, which is minus plus. So it will be 549.4. Now, if you see this term is very big than this, yes or no? How many of you agree that this delta H is very big than delta S? Right? Agree everyone? Agree? So obviously delta G is negative, which shows that reaction is spontaneous. Yes, everyone? Okay, very good. Next, till question number 7. Till question number 7. I guess question number 7 you would be easily, it will be easily solved. It is formula putting getting NCV ln T2 by T1 plus NR ln V2 by V1. We have already solved these problems. 8 to 11. Tell me, 8 to 11 everyone. 8 to 11. Kaishma, it was visible on screen. I was writing on screen. Just take 2 minutes, right? 8 to 11. Kaishma, it might be your net issue. Just try to leave and join again. Okay, right? Or just wait for 2 minutes. And for now, I'm not writing anything. Okay, for now, I'm not writing anything. I'm just giving you time to read question number 8, 9, 10, 11, because I think some of you have not even attempted these problems. Okay, just try attempting 8 to 11, right? We just have only this 5 questions, 8 to 12 only. Okay, so question number 10. Okay, before question number 10, anyone have any doubt before question number 10? 7. As I told you, 7 is just formula putting getting. Delta S is equal to NCV ln T2 by T1 plus NR ln V2 by V1. That's it. Just formula putting getting. T2 is given, T1 is given, V2 is given, V1 is given, right? And it is said that CV is also given. So just formula putting getting. Okay, okay. Check now, because everyone, can you see question number 8 to 11? Everyone, can you see question number 8 to 11? Yes? Okay, alright, thank you, very good. Karishma, just check your internet connection. Okay, so question number 8, 9, anyone have any doubt? 8, 9? So I guess 8, you won't be having doubt. 8 is again formula putting getting, right? 9, again delta G, formula putting getting, right? Okay, Karishma, you can leave and join again soon. 8 or 9, anyone having any doubt in question 8 and 9? Tell me everyone. 8, 9, any doubts? Before I discuss question number 10? Okay, okay, then no doubts in question number 8 and 9. Let's see question number 10. Just go through question number 10, everyone. Just go through question number 10. Okay, now question number 10 would be difficult. Okay, because of some concepts that you guys have not studied. Okay, right? So ideally I would have said to leave this problem, but let's see. Let's see. How many of you remember combustion reaction? Because we have studied this in class 10th. Anyone? How many of you remember combustion reaction? Okay, very good. So what is the formula of butane? C4H10 gas. Yes, right? Plus O2. O2. How many O2 will see? Will give me what? Since we have 4 carbon, we'll get 4 CO2 plus. Now, let's see how many H2O will get. H2O. Now, since we have 10 hydrogen, we will get 5 H2O. Yes or no? Now, see how many O2 is required. So, 4 O2 plus 5 by 2 O2. So, it will be 4 plus 5 by 2 O2. Yes or no? Yes, this is overall combustion reaction that we have studied in class 10th. Akshaya, you're getting? Everyone is getting? Tell me, everyone is getting? So this is your first step, yes or no? Okay, okay everyone. Step by step, right? Now just tell me, how many reactant product do we have here? Tell me, how many reactant product do we have here? Overall, I'm asking about everything. 4, right? Okay, very good. And out of these four, how many either reactant or product, right, are in their natural state? C4H10, is it in natural state? Means is C4H10 available like this only in nature, or you have to prepare it? Is it elementary particle? No, right? So I can say that no, it is prepared. How it is prepared? By combining 4 carbon, which is solid, right, plus, tell me, 5 mole of H2 gas, right? That's how it is prepared. C4H10. Yes or no? Tell me, yes or no? Yes or no? Everyone agree? What about carbon? What about CO2? CO2 is also prepared, right? CO2 is also prepared. How? C solid plus O2 gives CO2, right? What about H2O? H2O is also prepared. How? H2 plus half O2. Then we will get H2O. Any issue in this? Any issue in this? Step by step. I'm just trying to understand the problem now. Okay, now tell me, just tell me, this is the reactions which might occur because O2 exists in natural state. O2 is O2 only. Now just see the problem, and see the information. What is this? Right? Since we haven't studied this topic, so I am expecting this is called as heat of formation of C4H10. Heat of formation of C4H10, which is how much energy is required to form this. So for this reaction, delta H is given. Delta H formation is given, which is minus 130 kilojoule per mole. For CO2 is also given. For CO2, right? Tell me it is given how much? Because O exists in natural state. C exists in natural state, right? Got it. So energy of CO2 is same as energy of or heat of formation of combustion of S because it is combustion reaction. Na? Tell me, graphite plus O2 gives CO2. Is it a combustion reaction? Is it a combustion reaction? Yes or no? C plus O2 gives CO2. Is it a combustion reaction? Samya, Akshaya, Riya, yes, very good. This is a combustion reaction, na? So see, this is nothing but this energy, delta H, is equal to how much it is given? Minus 390. For water, how much it is given for water? Tell me for water, minus 860. Delta, sorry, not minus 860. What is it is given as? Delta H F for water, it is given as minus 286. Anyone have any issue in this? Tell me. Anyone have any issue? I have just written what is given. As simple as that. And one more thing is given, which is delta G is equal to minus 860. Right? So I have just written what is given. Yes or no? Tell me. Yes or no? Agree? I have just written what is given. That's it. I haven't written anything else. Everyone is getting this? Okay. Tell me one thing. Tell me one thing. Now, if this is your reaction and this is the delta H of individual component, what is delta H? Wait, I'll just change the pen. Tell me, what is delta H reaction? How many of you remember what is delta H reaction? Tell me, what is delta H of reaction? Summation of, right? H of product minus summation of H of reactant. Yes or no? Yes or no? How many of you remember this? How many of you remember this? Tell me. Just raise your hand. Yes, very good. Very good. Okay, so let's see. Let's see. In product we have what? Tell me, in product we have what? CO2 and H2O. Yes or no? In product we have CO2 and H2O. Yes? Okay, very good. Very good. Now, do we just add this? Do we just write this product is H of CO2, HF of CO2, delta H of CO2 plus delta H of H2O minus delta HF C4H10. Is it right to write? Is it right or is there some mistake? Tell me. Is this right or there is some mistake? Tell me everyone. Is there any mistake here? Is there any mistake here? Yes or yes, very good. See, when you talk about this energy, it is per mole. Yes or no, it is per mole. Agree? This is your per mole, right? It is given that it is per mole. But if you see this reaction, CO2 is how many moles? Tell me, CO2 is how many moles? CO2 is 4 moles, so it should be 4. 4 mole of CO2. H2O, how many moles? 5. And CH10, 1, right? Right? Got it, everyone? That's very good, right? So you can calculate this now. 4 into what? 4 into minus 130 plus 5. Sorry. Not 130. Not 130. 4 into CO2 now minus 390 plus 5 into what? 5 into what? Yes, minus 286 minus of minus 130. Got it, everyone? Got it, everyone? Everything is in kilojoule. Everything is in kilojoule. Okay? Okay then. Right? So if you calculate this, we will get something, right? You will get something. I'm not calculating, it will take time. So you will get something, and delta G is given. So delta G is equal to delta H minus T delta S. And what is being asked? Tell me, what is being asked? Entropy change. Can you calculate the entropy change? Can you calculate delta S, which is delta G, which is minus 860 minus delta H? We will calculate over here delta H of reaction by temperature. Can you do this? Did you get this problem? Yes or no? Everyone, did you get this problem now? Okay, very good. So what was the concept? It was writing these reactions, right? Okay. Okay, everyone. Okay, everyone. Now we have done question number 10. 11 and 12, two last problems. 11 and 12. 12 you can leave. 12 you can leave now. Okay. Right? 12 you can leave for now. 12 only advanced students should solve. Okay, question number 12. Only those who are practicing for advanced should solve, otherwise they can leave. Okay. Aryan, Avas, Shrihari, you guys can solve. Meet, Yasharan, you guys can solve. Siddharth is there. Question 11. Can you solve question 11 now? Tell me. Can you solve question 11 now? Now you understood what is question 11? S is given for each and every component. Yes or no? Can you calculate deltas of reaction? Deltas reaction, can you calculate? Tell me. Deltas reaction, can you calculate? What is deltas of reaction? It is S of CO2 minus S of CO or S naught, right? Plus half S naught of O2. Yes or no? And then you have to calculate delta G. So delta G is equal to delta H, or delta G naught is equal to delta H naught minus T delta S naught. Now is it formula putting it and getting? Tell me, everyone. Is it formula putting it and getting? Just reply, anyone. Okay. 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 Thank you, everyone. So only 27 students are present now. Okay. So those who are absent, they won't be admitted in next class, at least not in my class. Okay. Just tell them I've taken the screenshot of the class. Okay, everyone. Okay. Thank you, everyone. I hope you understood everything. Okay. Homework is 6.5 ka homework, and then in next class, which is next week, you will complete 6.3 and 6.4. Okay. Okay, everyone. Just message me, Karishma. Okay. Thank you, everyone. Bye, everyone. Okay, Aryan. I'll just check. Yes, Aryan. Correct. Okay. It's correct, Aryan. Bye, everyone.